Okay, for your first definition, okay, right here where it says any set of ordered pairs, that is the definition of the word relation. Okay, so legend at the top of the sign points to the word relation. Okay, a relation is any set of ordered pairs. So if you find a graph and it has ordered pairs plotted on it, then it is a relation. It doesn't matter what the pattern of those ordered pairs is. It doesn't matter if they go in a certain direction. If there are ordered pairs, then it is a relation. Okay, so it's a pretty simple definition. All right, the next definition that you need to write down is the word domain. Okay, so Legend, go over there and find the word domain. Good. Okay, everybody see where Legend's pointing? See how it's over there and it's on the left side of the X column? It's because if I say the word domain, then I'm talking about X values. So the definition of domain is the set of X values in a relation. Okay, your next word is range. Okay, can you just kind of point in the general direction of it? Or you can move my card out of the way if you want to. Okay, there's range. Legend pointed at range. And the reason that it's over there on the right side in the Y column is because range is the set of Y values in a relation. And then your last definition that you need to know is function. Smart guy. Okay, a function is a special type of relation that pairs each domain value with exactly one Y value. So therefore, this is important right here. X does not repeat. That's a big deal. Okay, put a star by that. X does not repeat. Okay, so when we look at example 1 says express the ordered pairs 1, 10, 2, 8, 3, 6, and 4, 4 as a table, as a graph, and as a mapping diagram. Hey. All right, so to express the ordered pairs as a table, you basically just do what you already know how to do. Now, my table got kind of cut off here, so I need to fix it. All right, so to express those ordered pairs in a table, I do my X values over here and my Y values over here. So I do 1, 10, 2, 8, 3, 6, and 4, 4. Okay? Then to express them on a graph, I just graph the ordered pairs. So I do 1, 10, goes up here at the top. 2, 8, go right there. 3, 6 will be the next one right there. And then 4, 4 would go about right there. Okay, so that's how you put ordered pairs from a table to a graph. A mapping diagram is kind of like, I don't know, these little bubbly things. So it's not very different from a table. You still put all your X values here and all of your Y values here. So all of our X values are 1, 2, 3, and 4. And then our Y values are 10, 8, 6, and 4. The only difference between a table and a mapping diagram is that you draw arrows to show like which X values correspond to the Y values. So like I draw an arrow from 1 to 10 because they go together, and 2 to 8, and then 3 to 6, and 4 to 4. So you just like draw an arrow across to show that they correspond. All right. So then it says, are the ordered pairs listed above a relation? So to answer that question, what I have to do is just know the definition of the word relation. A relation is any set of ordered pairs. So do I have a set of ordered pairs? Yes. So therefore, yes, it's a relation because they are ordered pairs. Okay. Then for the domain, we talked about domain a second ago. What is the definition of domain? The set of X values. So here, to find the domain, I can just look right there because domain is X values. And when you list domain, you have to put brackets around it. So a bracket is kind of a little squiggly line that looks like that. And I would say my domain is 1, 2, 3, 4, and then I close it with another bracket. And for the range, what is the definition of range? Any set of y values. So for my range, I also do brackets, and I do 10, 8, 6, 4. Okay. So then in example 2, it says give the domain and range of each relation. So this is a relation already. We already know it's a relation because it's ordered pairs. Okay, so now we have to find the domain and range. What is domain? The x values, right? So for my domain, this is how I'm going to write it. I'm going to put my brackets and do 6, 5, 2, 1. Okay, then for my range, what would I write in there for the range? Good. Okay, so that's the domain here, and then the range is here. Domain is always x, range is always y. Okay, then for example 3, okay, we're going to do the same thing. We're going to find the domain. Where do I find the domain? The x values, okay? So what would I list as my domain on this one? 1, 4, 8. Good. And then for my range, where do I find the range? In the y's. Good. Okay, so for the range, notice, oh, that's the worst bracket I've ever made. Notice we have 1, 4, and 1. But because that 1 repeats, I don't have to write it twice. Okay, you only have to write it one time. So I'm going to write 1 and 4 for my range. And then you would have like the 1 would point an arrow at the 1, and then the 8 would point an arrow at the 1. Like it would have 2 arrows pointing at it. You see what I'm saying? Okay, so flip over to the back. Okay, this is a little bit different. Notice on the front, when we were describing domain and range here, we were given like specific x and y values, right? And they were listed individually. On example 4, we're not given like individual values. We're just given a graph that has a line on it. So when that happens, you have to write your domain and range a little differently. Now, domain still represents x, and range still represents y. But what you've got to do is look at the x and y values that have the line on them, okay? So for my x values, okay, remember this is my x-axis. The line starts on the x-axis at the value 1 and goes all the way across to the x value of 3. Do y'all see how I came up with that? Starts at 1 and goes across to 3. Okay, so all of our x values are between 1 and 3, right? So the way that we write that, we actually learned how to write that on the last unit. The x values are between 1 and 3. Y'all remember that from the last unit? Okay, and they are inclusive. 1 is included and 3 is included. So because they're both included, I put little equal signs there underneath. They're always inclusive on these graphs. It will never be not included until you get to algebra 2. All right, so then for your range, okay, remember range is talking about your y value. So instead of looking side to side, for our range, we're going to look up and down, okay? So the lowest number is 2. The highest number is 4. So for my range, we're going to say our y values are between 2 and 4. Okay, so let's look at another graph where we have to describe the domain and range. Okay, so on example 5, okay, domain always talks about which set of values? Your x values, right? So for this one, I'm going to say my x values are between, and then I'm going to look at my graph, and where do my x values start? Oh, they start at 3, right? And then where do they end? At 7. So my x values are between 3 and 7. And then your range always talks about which set of values? Your y's. Okay, so my y values are between, okay, so I'm going to look up and down this time, 2 and 8. Good. Okay, so now let's look at example 7 here. Okay, on example 7 it says give the domain and range of each relation and then tell whether the relation is a function and then explain it. Okay, so on example 7 we're given specific values, right? So if you're given specific values, you have to make a list of those values for your domain. So for my domain, my specific values are what? 75, 68, and 125, right? Okay, then my specific range values are what? 2 and 3. Okay, now here's a new question. The question is it a function? All right, if you look back at the first page of your notes, it says that a function is a special type of relation that pairs each domain value with exactly one y value, and the main point is that the x values do not repeat. Okay, so if I'm looking here to see if example 7 is a function, I'm looking at the x values. So do any of my x values repeat? Therefore, yes, it is a function. So how would we explain that?
The x values don't repeat.
Perfect. X values don't repeat. Mm-hmm. Okay. So on example 8, what is our domain?
7, 9, 12.
Okay, what would be our range? Uh-huh. And 0. Good. So is this one a function? Okay, I hear yes and no. Okay, the definition of a function is that the x values do not repeat. So see how the 7 is going to -1 and the 7 is going to 0? Because the 7 has 2 little lines coming off of it, that means that that 7 is repeating. And since it's an x value, when x repeats, it's not a function. So no, this is not a function. And what would be our explanation?
X values repeat.
Okay, so x value 7 repeats. Okay, then on example 9, make that a little bigger. Okay, this time we're not given specific individual values. We have a graph. So we're going to have to do one of those between statements. And remember, domain is always describing which set of values? The x values. So our x values are going to be between something. So to figure that out, I'm going to come over here. I'm going to say my smallest x value is what?
-4.
-4. My largest x value is 4. So for my domain, I'm going to say the x values are between -4 and +4. The range always talks about which set of values? The y's. So I'm going to say my y values are between. Okay, so for y values, I look up and down. So -4 to +4. So would this one be a function?
No.
Why?
X values
Where?
-4 and yes, it would be.
Well, here's how you can tell based upon looking at a graph. See how I can draw a vertical line like that? If you can make a vertical line touch the graph in 2 places, it is not a function because that means the x repeats. So because I drew this vertical line and made it touch the circle twice, then I would say, no, it's not a function. And the explanation is, how did I explain that to you guys just now?
You can draw a vertical line and you can
Okay, so draw a vertical line. And what?
make you
And it touched twice, right? And it touched twice. Now, the homework is in a weird spot on your notes. It's like sideways because I ran out of room. So the homework is listed right here in the notes. All right? You guys have a great Friday. I'll see you on Monday.